Okay, this is one of my MCF recordings in a series on language and the mind and in cognition in general, and it's called the Human Conceptual Hub. And I'm going to talk a lot about communication and a little about multilingual processing at the end. Okay, advancing the slide. Here is the overview. First, a few personal preliminaries, background, what led up to this talk, just to give you a bit of context. Then a global description of the multilingual cognition framework for those who are less familiar with it. And then I'll get into the main dish, which is the conceptual system, and I'll talk about that both in the mind and in the brain. And then I will go on and talk about how it functions as a communication hub. I'll throw in a little tentative hypothesis about how syntax and the conceptual system evolved, and end up with a short account of how this works out in multilingual processing. And then I'll have about 10 implications or conclusions. Okay, bit of personal background. I realized going through a lot of the literature that we have produced, John Truscott and I, for the multilingual, the modular cognition framework, is that we talked a lot about grammar and consciousness and that kind of thing, and I came to understand that the conceptual system was actually something that is worth foregrounding, and because it is a very special system in human beings, and it's involved in communication generally, but also of course in language communication. And this train of thought was really triggered by a talk given by Asli Ozurek to this group in 2021, called Multimodality as a Design Feature of Human Language Capacity. I thought that was quite an original title, so it got me thinking. And then further on, there was a talk by Neil Cohn here, either to the Linguistic Circle or to this group, or both, on the visual language of comics. And his approach attracted me in particular because he also adopts a Jack and Off perspective with regard to the architecture of language, which is a generative linguistic perspective, but not the classic one. And then as a result of that, I gave various presentations, including to this group, on multimodality. And just a short while ago, a few weeks in fact, a paper of mine came out, which I submitted in 23, called Communication in Humans and Other Primates, because I'm interested in other primates as well. Okay, starting now with the psychobiological perspective, there are five points to make here. Firstly, the mind and the brain are two sides of the same coin. Everyone who talks about cognition, about the mind, who's researching some aspect of the mind, needs to commit to some idea of what the mind is. We know what the brain is, but what is the mind, right? And in this perspective, the mind is a biological phenomenon. It's not the same as the brain, but it is intimately connected, as I say, two sides of the same coin. And the best way of putting it has been used, quite a long time, and that is to talk about the mind as the brain's software, and I call it biological software. This idea of the brain being the mind being the brain's software, I think was introduced by John von Neumann, although he had quite a different perspective and quite different intentions in his research. Important, of course, for those who think, oh my God, you're comparing us to computers. No, we're not computers in that digital sense. And of course, in particular, the software that runs us, our software, us, in fact, was not designed. No one designed it, but it has evolved and is presumably, we hope, still evolving, because it's by no means perfect. And the fifth point is we know more about the mind than about the brain. So I always have a problem here about the word neurotypical and neuroatypical. People have used neuro because neuro, of course, is very in at the moment. There's a lot of research into the brain, which is throwing up some interesting stuff. But in actual fact, since we know really so little about the brain still, and more about the mind, we should really talk about it being psychotypical and psychoatypical. Of course, the brain can deliver the same functions, the same behaviour in different ways. So everyone's brain is different. Anyway, that's sort of bee in my bonnet, which I'll pass over quickly. But I'll add an extra point, and that is in both areas ignorance still dominates. So there's so much more to find out. So we have always, of course, to be very modest. So I'm going to talk basically about the brain software, and to do this I've been tempted to put this little image on the front of my book, which, if it ever gets published, on the mind, which I'm in the process of writing now. And as you see, it recalls the system of the London Underground. So I'm comparing here the brain software, as it were, to a metro, a very simple metro system, right, with an outer ring and an inner ring, which I'll go into in a minute. But more specifically, you can see a little more detail in this one, this larger one, and you can see that there is an outer ring, a blue ring, which covers the perceptual systems, the ones that receive input of different sources, our ears, our noses, etc., and creates from that input the first level of processing. This is cognitive processing. The first level that creates representations of taste, of smell, visual sense, hearing sense, body sense. That's probably the most uncontroversial bit of the whole piece. But this, of course, is not enough. I mean, we share this with an awful lot of other animals. A deeper processing is required, and that is done by the so-called stations, the systems, the functionally independent systems on the inner ring, two of which you notice have to do with linguistic structure. That's the Jack and Doff system. If you don't believe in Jack and Doff's approach, then you just have syntax. And spatial structure, meanings, values and emotions and movements. We're going to be concentrating on meaning, which means the conceptual system, that's why it is marked C, and syntax. Right, that's going to be our main interest now. And of course this means how the two interact, because these are all functionally independent systems. They each have their own specific way of producing representations. They also interact, and the way they interact is not shown here because there are interfaces, of course, connecting all this up as a network. But here is the network between syntax and the conceptual system, allowing, for example, particular syntactic structures to be triggered, to be associated with particular meanings. Okay, so dealing again, continuing with the software, let's look at the conceptual system in the mind. And the question is, what does conceptual mean? What does it cover? Well, you might easily substitute the word semantic for it, because that's perhaps more widely known. The trouble with semantic is a very, very polysemous term. It has many meanings, therefore it's a bit slippery by itself without detailing exactly what you mean. If you go to some people, you might say conceptual is just the same as semantic, but if you go to psychologists, especially general cognitive psychologists, they make difference between a semantic and episodic memory, for example. So episodic memory is different from semantic memory. There's a distinction there. Semantic doesn't cover everything, but this is particularly true if you go to linguists, because semantics doesn't even cover all meaning conveyed by linguistic structure, because you have a distinction between semantic meaning and pragmatic meaning, discourse meaning and context, contextualized meaning. And the context might be situational, or it might be in the utterances which have already been uttered, so the text in which it is embedded, right? So semantics, we have to be absolutely certain. So I'm going to come right out and say that conceptual covers all areas of meaning, every area of meaning: semantics, linguistic pragmatics, discourse principles, as well as non-linguistic meaning, meaning that is not easily or at all conveyed in language, meaning of icons, meaning of comic strips, as Neil Cohn has shown, comic strips, that is to say, without bubbles and text in, so they can follow a sequence of events entirely without language. Okay, bottom line, conceptual is all meaning. Right, so moving on. As I said, all the systems in the mind, the stations in the metro, the two rings, as it were, all these systems are functionally specialized. They're functional. That's why the word modular exists in the modular cognition framework. They're modular. Modular is a bit of a dangerous word because it summons up particular associations that do not apply. So that's why I prefer to call them functionally specialized. Each one has a special, unique function in the mind and contributes it to the whole. More specifically, it means that they're all run according to their own unique biologically inherited set of principles. So the visual system, for example, is run according to the biologically inherited set of visual principles, constructing visual representations which are different from auditory representations, which are different from any other representations, but they're also different from visual representations in fellow species. And the only way they can be that way is because we have inherited some particular way of constructing them. So we construct a representation of a visual scene. We do it with different principles than the soundscape, for example, or in this case, the world of meanings. So, what is general cognition exactly? This is an awkward term now because it's a very vague description, and very often when people talk, especially people who are trying to avoid accepting that we do not have a particular biologically endowed linguistic ability, and would like to account for everything in sort of so-called general cognitive principles, I have to add that very much what they're talking about is usually here is the conceptual system. And the conceptual system is also managed according to its own conceptual principles. We shouldn't be surprised about that because people working in linguistics on semantics are quite clear that to formalize meanings requires a very particular kind of set of principles which are different from syntax. And apart from domain-specific principles, there are indeed general principles that hold for all systems, and these cover how representations grow in the mind, right, in response to experience. It covers how they're activated or co-activated together. That's the interaction between the different stations, and it also covers what you might call a drive to coherence, because the mind has this drive to make sense of things. Sometimes it can't make sense of things, but it gets some input, a particular system gets some input, and it tries to make sense of it, tries to put it in some kind of order according to its internal principles. Okay, so the drive to coherence will be a general principle. But over and above that, of course, you have all the other principles of each particular system, which I've just mentioned. So let's have a quick look at the conceptual system in the brain, because it's important in this particular biological perspective that we keep these two kind of running in parallel, so that we can, in principle, try to relate mind phenomenon with brain phenomenon. So here is a picture of a bicycle wheel, and it's a deliberate reference to a particular piece of research which was started not so very long ago, more recently Lambon Ralph, who is a researcher who with many others has been researching in this particular area, published with associates a review of the kind of state of the art in semantic cognition in Nature Reviews Neuroscience, as you see, in 2017. Basically what he said is that there's growing support and growing evidence indeed for a functionally independent semantic brain system. This is very much not the default situation prior to this, because people did not want to accept there was a brain system which was specifically to do with meaning, and they wanted to do it in some way, especially people who like the idea of embodied cognition. And the evidence that he quotes is that when things go wrong, pathology, as you can see here, centered on the anterior temporal lobes. These are in the head on either side. Degrades knowledge across all semantic domains and all receptive expressive modalities. So however you express meaning, this will be damaged if this particular area in the anterior temporal lobes are damaged. This indicates that there is some kind of centralized system which is important for semantic cognition, for meanings. And it was proposed at the time that the distributed cortical semantic network is anchored by a cross-modal hub. In other words, the processing of meaning, as almost all brain processing, covers many different areas of the brain at the same time, which are linked together, but it is anchored, as it were, by a cross-modal hub, hence the hub in the middle of the picture there, in the anterior temporal lobes, and this mediates learned associations amongst all these other things. If you like to think of that metro thing, all, for example, the sensory systems on the outside, and the motor systems in the red ring, the linguistic ones in the red ring, the affective systems in the red inner ring, other surface representations distributed throughout the cortex. So this seems to mediate it, and when it's damaged, everything else gets affected as well. And it's called the hub and spokes model. And when I came across this research, I was very, very happy, because we'd already got to this sort of conclusion in our mind version, or software version. So moving on, let's now look at the conceptual system as a hub, in this case as a communication hub. Right. So if you think about it, all communication begins and ends with the mind's conceptual system, right? Or whatever you like to call it. It's the message coding and decoding center. This is where it starts and finishes. And as in the brain, it functions in the mind and the software as a hub with radiating interfaces, which are like the spokes in the hub and spoke model. Right, I'm going to illustrate this. It's there, marked C is the conceptual system, deals in meanings. And recall that I said I hadn't put in all the interfaces that the network that connects these various ones together, but here they are for meaning. And as you see, they reach out both to systems on the inner ring and the outer ring, essentially forming a hub. So, for example, a particular movement can have a meaning associated with it, and that is enabled by the interface between the motor system and the conceptual system. a piece of syntax can be associated with a particular meaning, right? A noun, for example, and cat concept. And I mean, a smell can be associated with meaning, a particular visual image, particular taste, particular body feeling, and a particular sound. So this is the system that makes many things meaningful, right? It's by itself. It doesn't do much. It's really it acts almost as a crossroads for a whole set of meaning associations involving many things in different systems. You might call it the hub and interface model, if you like. There are two aspects of the conceptual system. One is that it's amodal, and that means it's not specifically associated with a particular perceptual system. It is, as it were, distinct from the perceptual systems. And the other thing is the way in which meanings are conveyed and understood by humans is multimodal. It's done in very different modalities. So it's an amodal system with equivalents in some other species, right? Fellow primates, for example. And most communication is multimodal, with or without the direct participation of syntax and phonology, right? So with or without linguistic structure, the communication system, communication can take place using other modalities. This here is my tentative hypothesis. I thought I'd just mention it. You might be curious about it. So, and I would, for want of a better meaning, a better title, I would call it the synergy hypothesis. And the synergy hypothesis has something to do with the relationship between these two systems, right? But how did it begin? Well, as we know, the syntax, or as I think we should know, the syntax is a functionally specialized system. It has its own principles, its own syntactic principles for the creation and modification of syntactic representations. You can't put together a syntactic structure according to visual principles, and it does this on exposure to input. Input coming into the syntactic system causes these structures to be built, and importantly, it does it from exposure to input from an early age, as we all note here, because we know about language acquisition by children. But how did syntax evolve? How did it evolve? Well, a tentative hypothesis using the modular cognition framework is that traits from the conceptual system, right? So there was no syntax originally, but traits from the conceptual system were co-opted and adapted. Co-opted and adapted, you may know, are technical terms used in evolution theory. But with a much earlier maturation schedule, right? So whether that was an important motive behind it, if you can call it a motive, because it takes a conceptual system a long time to mature. We become cognitively mature much later in life than we do become syntactically proficient, and so what you got then is two new systems now instead of one, and the interaction between these two works both ways. That's the synergy idea, right? So the syntax, now independent syntax, starts to affect the conceptual system in two kinds of ways. The first one is quantitative, right? So the way of structuring and restructuring in syntax, which is much more advanced than how you would put together meanings by themselves, just using conceptual principles. This means that the system will, at the very least, get many more concepts, I think. Okay, but perhaps more importantly, much more importantly, I think, is these concepts become more complex. Right, the complexity provided by syntax allows for very many more complex concepts to be built. So that's okay. I'm not stand behind my hypothesis, with my, guns blazing. But there we are. Passing over that anyway. Let's look now at languages. Let's see how the conceptual system functions. Is important function in language. Putting syntax and phonology slightly in the background for the time being. So here is the linguistic system, according to Jackanoff anyway, and there is an interface, of course, a very much travelled interface between syntax and phonology, because syntactic structures need to be associated directly with phonological structures in order to build a proper language. But we now introduce the conceptual system, which is the focus of this talk, and the conceptual system is not a linguistic system per se, right? Although it's very much involved, of course, in language, it is not, strictly speaking, one that delivers linguistic structure. These are delivered uniquely by these two systems, or these one system if you're a classic generative system linguist. So the linguistic system, the two module one, and meaning, right? Now let's look at a particular language, which is Hausa, which I allegedly used to speak fairly fluently when I was 4 years old. It's spoken in West Africa. It's the third most popular African language on the continent, most widely spoken, I mean. It's a lingua franca in the northern area of West Africa, particularly around Niger and northern Nigeria. And the word for house is gida. Okay, so you might think, well, obviously there's a syntactic structure for gida, there will certainly be a phonological structure for gida, and there will be a kind of concept here for house. But as we're going to see, it's going to be a little more complicated than that. Indeed, you have a house concept, which itself, of course, is a complex concept because it's put together by smaller representations representing particular features that are characteristic of houses and not fish or dogs. But here I'm just calling it a single concept for the sake of simplicity. Then it's connected with the concept of language, which might not be very clear if you're a small child, but it'll be how mummy talks or how daddy talks or something. And it's associated with Hausa, right? And there are many other contextual concepts which are associated with it. So in actual fact, rather than being a single isolated concept meaning house, it is in fact a whole network of associated concepts which come with it and are co-activated with it. And you might imagine that the context, the conceptual concepts were acquired along with the word house and the word gida. So all of these will be co-activated. So associating and co-activating representations written in the same code, as we saw here, with everything is written in conceptual language, conceptual code. It can take place within a particular system, but of course, as we saw earlier, you can associate representations in different languages, and this takes place outside, and the networks that get formed, the networks of association, are called schemas. And I will now demonstrate one. I will demonstrate one that looks like that. That's the conceptual system and the two linguistic systems. And for visual convenience alone, I should say the following two linguistic examples were very simple ones. They could be much more complex, but I don't have space on the screen. Right. So I've taken a possessive construction, which is Gidan Ali. As we see, the word house has an attached part to it, which is the possessive marker, and that is put on the possessed object, right? And you see there the possessor it comes in phrase final sequence, and that simply means house, possess, alley, right? So that's a schema, and all of these things that you saw in the schema that I just illustrated, all of these things, the syntactic structure, the phonological structure, and all those contextual structures, including the meaning of house, will all be activated together. Now let's have a little fragment of that inner ring, because all of this is taking place in the inner ring, and that is the interface that enables us to link a piece of syntax with a piece of conceptual structure, and this is the one we saw earlier between the two linguistic systems. So here we have now, instead of just house, I made it more complicated. I've got the conceptual structure of this, right, and all those conceptual concepts that I mentioned before, and this in the course of acquisition gets associated with a linguistic possessive structure. So now we've got a schema involving two things which will be co-activated whenever the situation arises, and now I add to this schema a third participant, and that's the house of phonological structure. So this will all be activated in parallel. This is what the house speaker and in the 4-year-old Mike has learned, and there we are. And note, I've had to kind of even crunch all these things together. The complexity of this is even more complex than I've been able to show. It's just the point. Okay, now look at the equivalent schema for English, right? And of course, what we would say would be Ali's house, and in which case we've got the possessive marker, the possessive concept, and we've got Ali and we've got house. And as you see here, when it's expressed in language, we will find that the possessive marker is now attached to the possessor of the house and not the house, and indeed the possessor comes first and the possessed object comes second. That's what the syntax decrees. Why does it decree that? Because there's an association here for English. There are English concepts, presumably acquired in various situations where English was spoken, and this will trigger the English possessive structure and the English phonological structure, and that's how we get Ali's house. So we got Gidan Ali and we got Ali's house. Now, at 4 years old, I was presumably a bilingual, so any bilingual Hausa English speaker will of course have both these structures. Now this is where I have to introduce the special function of the affective system, and the affective system is here. It's actually also a hub, and I'm interested in the interaction between these two for the time being. Okay, so suddenly here I am, or here is the Hausa English bilingual, and as we know, when you activate one language, all the other languages are activated to some degree at the same time. So potentially we've got a really serious conflict with the danger that chaos will ensue. Right. So there has to be some mechanism for explaining how one schema somehow comes out on top in particular situations and not in others. Okay, so we've got now in this bilingual we have not only all the Hausa type concepts, we've got the English contextual concepts, including of course English and Hausa and language, and we've got the same conceptual structure here with Ali possessing a house. So because this is the meaning structure, the conceptual structure. This is what people would really like there only to be if without the language module. But there it is anyway. This is a conceptual This is, if you like, semantic structure. But we've also got these two. So all of this will be co-activated, whether you're speaking Hausa or whether you're speaking English. This creates sort of a potential chaos, which I have got this rather alarming flash of lightning in all directions behind. What happens? Now this is where the affective system comes into its own, because the affective system contains values. It contains positive and negative values. It also contains the basic emotions, but these basic emotions can also be categorized as to whether they're positive or negative. So joy will have, as part of its makeup, a positive value, and disgust will have, as part of its makeup, a negative value. So these negative values are also independent, and they can be attached. So and as it's a hub, a bit like the conceptual system, you can attach values to pretty much everything, right? In this case, you can attach it to a particular schema. And the effect of this, when a thing is valued, when your processing of a context or a situation makes you value one particular schema over another, it has the effect of boosting the activation level. That's the mechanism. Okay, so in the case of English situation, the English ones are valued more highly, and the case of a Hausa situation, the Hausa ones are valued more highly. The result is that the English schema, or respectively the Hausa schema, are then foregrounded and receive greater activation, and, as it were, stop chaos happening, with everything being activated with equal activation at the same time. That's the mechanism. The mechanism is powered from the affective system. That's the basic idea. Okay, but of course, you know, there are situations that bilinguals encounter where they have to perform code switching, right? So there are people around, some of which are bilinguals that have both languages, and other people who are either bilinguals that have not one of these, only one of these languages, or simply monolingual. And if you're all sitting around together talking Hausa together, and someone walks in who you know is not a Hausa speaker, you will switch to your other language. So the situation can change minute by minute, second by second, and the processing of the situation will then highlight certain concepts as being valued and other ones being not. So you can see the importance of context, or rather the context as it's processed by the mind, as driving the value of one schema over another. So here we have the English one is still quite highly activated. That's why it's in pink, or the Hausa one wins in this case, but in walks the English person, it'll be switched round. So now I'd like to finish with 10 conclusions or implications. So what is the conceptual system? Well, it's processing in the conceptual system creates, stores, activates all kinds of meaning. That's what it does. It's one of the mind's functionally specialized system with its own innate principles, right? It works the way humans construct conceptual representations. It substitutes for what is generally referred to loosely as general cognition. What are its main functions? Well, its main function perhaps could be as a processing hub. It's multiply connected, making it the central core of knowledge that is based on meaning. Not all knowledge is based on meaning. Not all knowledge is based on meaning. For example, a visual or an auditory, a sound representation on that outer ring, right? An auditory representation has no meaning. It is meaningless. The only way it can get meaning is by associated with a structure in the conceptual system. So by itself it is meaningless. It is knowledge, but it's meaningless knowledge. But we use the knowledge for all of it. Okay, and the conceptual system is where all communication begins and ends, whatever modality is involved. So it is really the central core of communication, whether or not language is involved. What are its main functions? Well, its main functions are schemas that radiate from the CS, connecting up with a great many different kinds of representation, right? We've already seen that. So it means that there are very large patterns of co-activation across the mind as a whole. So what does that mean? It means that in dealing with meaning, whether or not language is involved, you are exercising a very large amount of your system, and this goes for the brain as well, of course. The thing is that observable, measurable behaviour will only feature the dominant patterns. So take our bilingual. If the bilingual is speaking English, the observable behaviour will all be English. That's what you would measure if you are interested in bilingualism, which I think we all are. But many other competing structures are being co-activated at the same time. So they form what you might call online background chatter. So as you're speaking English, there, as it were, a lot of Hausa background chatter, and this chatter, of course, will be have some physical signals in the brain. So if you're looking at brain activity, you can expect not all of it to do with English, and it may influence behaviour, and it probably will, and it needs to be taken into account in the analysis interpretation of data. And that brings us to the end of today's talk. I hope you enjoyed it, and I hope you can subscribe to the YouTube series, of which this is, I think, the 7th or 8th in the series on language and the mind. But as you will notice from the Cognition Framework website, there are lots more presentations to be heard also on the mind in general, and some PowerPoint presentations. So this is all for the time being. I hope to be back soon with yet another topic. Goodbye then.